Welcome to the deep dive. You know asteroid mining. Well, today we're going to look at the tech that could get us there.
Yeah.
We've got this research chapter, dives deep into electric and nuclear propulsion, and
It's going to be fun comparing those, right?
exactly, so much potential out there, ready to dig in.
Absolutely.
Yeah.
Yeah, it's a huge challenge, especially when you start thinking about, how far these asteroids actually are
Oh, for sure.
and how much stuff, how much material we'd want to bring back, ideally.
It's a whole different ballgame than just going to the moon, right?
Right.
Deep space, heavy cargo, we need some serious engineering to pull it off. So, first things first, can you remind us why we can't just stick with the good old chemical rockets, the kind that got us to the moon?
Well, think of chemical rockets like, those drag racers.
Okay.
They're great for a short burst of power, getting you off the ground into space quick.
Yeah.
But for long hauls, the fuel efficiency just isn't there.
Right.
You'd need a massive, ridiculously huge fuel tank to even get to an asteroid, let alone come back with a load of valuable minerals.
Yeah, that makes sense. So, for asteroid mining, we need something more like, I don't know, a hybrid car on a cosmic road trip, right?
Exactly.
Something that sips fuel, and that's where these fancy propulsion systems come in.
Yeah, yeah. And when we're talking about efficiency in space, we use this thing called specific impulse,
Okay.
or ISP for short.
Okay.
It basically tells you, how much thrust you get out of each bit of propellant. Higher ISP means less fuel to change your speed, which is super important for those long treks.
Gotcha. So higher ISP, more bang for your buck fuel-wise.
Exactly.
Okay, let's talk electric propulsion.
All right.
Honestly, it sounds a little Star Trek-y to me, but hey, I'm ready to have my mind blown.
It does sound kind of futuristic, but electric propulsion, or EP, is already a thing,
Oh, wow.
We're not talking warp drive here, not yet anyway, but it's a pretty big step forward. The basic idea is using electrical energy to speed up charged particles, we call them ions, to create thrust. And what's cool is we can get really high ISP values, like sometimes thousands of seconds.
Ooh.
For comparison, the best chemical rockets we have, they max out around like 450 seconds.
That's a huge difference. So it's like trading in your gas guzzler for an electric car that can go across the country on one charge.
Yeah, something like that.
Are there different types of these electric propulsion systems, or is it all the same basic idea?
There's actually several types, each with their own pluses. This research chapter, it focuses on three: ion thrusters, Hall effect thrusters, and pulsed plasma thrusters.
Okay, let's break those down. So ion thrusters, what's the deal with those?
Ion thrusters, they're probably the most famous type of EP, I'd say.
Sure.
They use electrostatic forces to push those ions and make a super gentle but crazy efficient thrust. You might be surprised they're already out there working. Missions like NASA's Deep Space One that flew by an asteroid, a comet even. And ESA's got Bepi Colombo. It's on its way to Mercury right now.
That's impressive. So they're already out there doing the real work in space. What about Hall effect thrusters? Those sound cool.
Yeah, Hall effect thrusters, or HETs, they're a bit more powerful than ion thrusters.
Okay.
They use magnetic fields, kind of trap electrons, and then those electrons ionize and accelerate the propellant. It gives them a higher thrust-to-power ratio, meaning they can get more thrust for the same amount of power, right? And here's something fun. You've probably used Hall effect thrusters without even realizing it.
What? How?
They're in communication satellites, the ones orbiting Earth, providing signals for, GPS, satellite TV, all that stuff.
Wait, really? So the same tech that helps me find the nearest coffee shop could also help us mine asteroids one day? That's wild. Okay, last but not least, we've got these pulsed plasma thrusters. What are those all about?
Pulsed plasma thrusters, or PPTs, work a little differently. They make these short bursts of plasma using high-energy pulses. They're really good for smaller spacecraft. CubeSats, those are becoming more and more popular for a bunch of different space missions.
Yeah, I've heard of those.
Imagine a swarm of tiny mining probes, all powered by PPTs, zipping around an asteroid field.
That's a cool visual. Okay, so we have these awesome, super efficient electric propulsion systems that could totally change space travel and asteroid mining. But there's got to be a catch, right? There's always a catch.
Well, yeah, there is one big challenge: power. These electric propulsion systems need a solid source of electricity.
Right.
Closer to the sun, solar panels, that's doable. But when you go farther out, where the sun's light is weaker, we're going to need something else.
I think I see where you're going with this. Are we about to go nuclear?
You got it.
Right.
Nuclear power. That's the key to really unlocking the potential of electric propulsion, especially for asteroid mining. And that's actually a perfect segue into the next part of our dive today. Nuclear propulsion, it kind of gets a bad rap, you know,
Yeah.
because people think, oh, weapons, scary stuff.
Right, right.
But honestly, it's a really powerful tech, super versatile, and it's got huge potential for, peaceful space exploration.
Yeah, I get it. It's got that like sci-fi vibe, maybe even a little bit, I don't know, intimidating.
Yeah.
But I'm ready to hear how it could actually work for, getting us those asteroid riches.
Okay, so basically it all comes down to using the energy from nuclear reactions to make thrust.
Okay.
There are two main ways to do that. Nuclear thermal propulsion, we call it NTP, and then there's nuclear electric propulsion, or NEP.
Okay, so two flavors of nuclear propulsion. What's the difference?
All right, imagine you're trying to move something really heavy.
Mhm.
NTP is like pushing it directly using brute force.
Mhm.
It uses a reactor to heat a propellant, usually hydrogen, to super high
Yeah.
temperatures. Creates this powerful jet of hot gas that shoots the spacecraft forward. It's not the most fuel efficient, but it gives you a lot of thrust quickly, which is important for certain things like, getting off Earth with a heavy load.
Okay, so NTP is the workhorse, gets all the mining equipment out to the asteroid belt.
Exactly. And once you're out there, NEP takes over. It's more like, think long-distance runner. Instead of heating the propellant directly, NEP uses a reactor to make electricity. And that electricity powers those electric thrusters we were talking about before.
Right.
So now you've got that crazy high ISP, lets you travel really far without using much fuel at all.
Ah, so it's combining the power of nuclear with the efficiency of electric.
Yes.
Best of both worlds.
Yeah, exactly. And this opens up some seriously cool possibilities for these missions. Imagine a spacecraft uses NTP to zoom out to the asteroid belt, then switches over to NEP to move around efficiently and you bring back all those mine materials. Or picture a mission going way out to the outer solar system where there's not much sunlight. You could run entirely on NEP to explore and basically mine those distant asteroids.
That's amazing. But I gotta be honest, the idea of putting nuclear reactors in space makes me a little nervous. What about safety?
I totally get it. Safety is like the #1 priority with any space mission, especially when you're dealing with nuclear stuff.
Yeah.
But these reactors, they're designed just for space. They're not like, mini versions of what we use on Earth. They're compact, incredibly tough, and shielded to keep that radiation down to a minimum.
Okay.
Plus, they go through crazy testing to make sure they can handle, the rough conditions of spaceflight.
That's good to hear. So it's not just like strap a reactor on and blast off. There's a lot of careful engineering involved.
Oh, absolutely.
Hmm.
And even beyond reactor safety, there are other challenges like keeping things cool. These systems generate a ton of heat, and getting rid of that heat in the vacuum of space, that's a big deal. And then they're storing the propellant. If you're using something like liquid hydrogen, it has to be kept super cold. So you need these like high-tech storage systems to keep it from boiling off during those long trips.
Sounds like a fascinating field, but incredibly complex. Okay, let's bring it back to asteroid mining. We've got electric propulsion, nuclear propulsion, both on the table. How do they actually compare? What do we need to think about when choosing the right system for a mission?
Comes down to a few key things: thrust, specific impulse, and where you get your power from. We already talked about ISP, that's the fuel efficiency. But let's dive into thrust. That's basically how much force your propulsion system can produce.
Okay, so who wins in the thrust department?
If you need raw power, nuclear is the clear winner. NTP, remember that heats the propellant directly?
Yeah.
It can generate way more thrust than any electric system. Think of it this way. If you need to move a mountain, you're going to use a bulldozer, not a shovel. NTP is the bulldozer in the world of space propulsion. Perfect when you need a lot of thrust fast, like, escaping Earth's gravity or making a quick change in direction.
Gotcha. So NTP is the sprinter. What about electric propulsion then?
Electric propulsion, that's more like the marathon runner. Provides lower thrust, but keeps going for a long time. Slowly builds up speed. Perfect for those long trips between planets where using as little fuel as possible is super important. Remember ISP. That's where electric systems really shine. Get the most out of every drop of propellant.
Makes sense. High thrust versus high efficiency, each has its own pluses. What about the power source, though? Is that a big factor, too?
Definitely. One of the best things about nuclear is that it powers itself. The reactor provides all the energy you need to make that thrust.
Right.
Electric propulsion, though, it can use solar panels or nuclear reactors for power. Solar's great if you're closer to the sun, but it gets weaker the farther out you go. For missions to the asteroid belt or beyond, you pretty much have to go nuclear, especially if you want to operate for a long time.
So it's like choosing between, I don't know, a gas-powered car that needs to fill up all the time versus an electric car that you can just plug in anywhere or even generates its own power.
That's a great analogy. And just like with cars, the best choice depends on what you need it for and what kind of trip you're taking.
Yeah, starting to see the bigger picture here. No one perfect solution. It all comes down to the mission and what trade-offs you're willing to make.
Exactly. And that's what makes this field so exciting. There's so much room for innovation, for making things better, and the possibilities are endless. Speaking of possibilities, we haven't even touched on the future of propulsion tech, and that's where things get really crazy.
Oh, I am definitely ready for some crazy. Listeners, stick with us as we explore the absolute cutting edge of propulsion technology and what it means for our future in space. This is going to be good. Okay, we're back, and my head is spinning from all this talk about electric and nuclear propulsion. But we've only just scratched the surface, right?
Yeah, definitely.
This research chapter mentions some seriously futuristic stuff, hybrid systems, even something called beamed power. We're going full sci-fi now, aren't we?
It does sound a bit like science fiction, but these are real concepts that scientists and engineers are working on right now. The future of space propulsion is all about, like, pushing the limits,
Right.
combining different ideas to make systems that are even more powerful, efficient, and versatile.
All right, I'm all ears.
Yeah.
Let's start with those hybrid systems. What makes them so special?
Remember how we talked about NTP and NEP, and they both have their pros and cons?
Yeah.
Well, hybrid systems, they try to bring those two together, get the best of both worlds. Imagine a spacecraft that uses NTP for quick bursts of acceleration, like, to break free from Earth's gravity or make a big course correction. And then it switches over to NEP for cruising along for a long time and for maneuvering around an asteroid.
So it's like having a sports car for the quick sprints and a fuel-efficient sedan for those long highway drives. You use the right tool for the job depending on what you need at that moment.
Exactly. And that kind of flexibility, that could be a game changer for those complicated missions like asteroid mining. You could have a spacecraft that can travel quickly between Earth and the asteroid belt, but then also be super efficient when it's working around an asteroid and bringing those mined materials back home.
Yeah, that makes a lot of sense. What about those futuristic reactor designs you were talking about before?
Oh, yeah,
Are we talking even smaller, more powerful reactors?
we are. One of the most exciting areas is compact fusion reactors. Unlike fission reactors, which split atoms to release energy, fusion reactors, they fuse atoms together.
Okay.
That's like what happens in the sun.
Oh.
And this has the potential to make a huge amount of energy with almost no radioactive waste.
Fusion power, that's like the ultimate goal for energy, isn't it? It's amazing to think we might one day power spacecraft with fusion reactors. It almost sounds too good to be true.
It's a long-term goal, for sure, but it has potential. And for the nearer future, there are other cool developments in reactor design that could change things a lot. For instance, there's a lot of research happening on dynamic power systems, which can change their power output depending on what's needed. That would be super helpful for asteroid mining, where the energy needs changed a lot during different parts of the mission.
So it's like having a smart power grid for your spacecraft, making sure you always have the right amount of energy when you need it. That's incredible. Okay, now I have to ask about something that really caught my attention. Beamed power systems.
Uh-huh.
Are we talking about using lasers to send power to spacecraft in space?
That's the basic idea, yeah. Beamed power means sending energy wirelessly using lasers or microwaves.
Wow.
So picture this. You've got a spacecraft with electric thrusters, but instead of having a big, heavy nuclear reactor on board, it gets its power from a beam of energy coming from Earth or maybe a space-based power station.
It sounds like something straight out of a movie, but it's seriously being considered. That's incredible. What would be the benefits of beamed power for, asteroid mining?
Well, one of the biggest is that it could make spacecraft a lot lighter and simpler. You wouldn't need to carry those heavy power sources with you.
Right.
That means you could launch bigger payloads or send spacecraft on much longer missions. And it could also open up new ways to use electric propulsion in deep space where solar power isn't really an option.
So beamed power could be a game changer for those long missions to the asteroid belt and beyond. Are there any other advancements in specifically electric propulsion that you're particularly excited about?
One really interesting area is in situ resource utilization, or ISRU. That's basically using resources we find on asteroids like water ice to make fuel for the spacecraft. Imagine a mining spacecraft that can refuel itself using stuff it gets from the asteroid.
Wow.
That would let missions last much longer, and we wouldn't have to depend on Earth for resources as much.
That's amazing. It's like creating a self-sustaining little ecosystem for space mining. It's incredible to think about how far we've come with propulsion technology and how much more we can still do in the future. It's really inspiring to see the creativity and hard work of all those scientists and engineers out there pushing the boundaries of space exploration.
Absolutely. The things we've talked about today show how important this moment is. We're on the verge of unlocking the potential of space resources and really exploring the universe.
This deep dive into the world of advanced propulsion has been incredible. We covered the basics of electric and nuclear propulsion and even went into the mind-blowing possibilities of hybrid systems, beamed power, and ISRU. It's clear that the future of space exploration is bright, filled with innovation and a desire to explore the unknown.
And to wrap things up, I'd like to leave our listeners with a question. If you had all the money in the world and the best propulsion experts working with you, what kind of asteroid mining mission would you create?
That's a great question. We encourage you to check out the research chapter we talked about and let your imagination run wild. The possibilities really are endless. Thanks for joining us on this exciting journey. Until next time, keep exploring.